Hello everybody, this is Mr. Strager back again with another Big Ideas lesson, and today we are starting Unit 4. We are in 4.1 on page 98 of your student journal. When it comes to Unit 4, it builds off of what we learned in Unit 3. So in Unit 3 we learned all about lines and how to represent them. Unit 4 is pretty much the same thing. Except this time, we're going to learn how to use them, not just how to represent them. Before I go any further, I am going to scratch off this definition right here. We will not be going in depth about linear models. In general, this unit has a lot of vocabulary that we've already sort of talked about. We've already mentioned that a linear model is basically just a way of representing a linear equation in real life. So there's no need to give a formal definition for it. In Unit 3, we asked ourselves, how can we use lines? More specifically, how can we use the equations that give us lines? In this unit, we're going to be changing that slightly, and we're going to be instead looking at how can we make equations of lines? So there's one rule that we talked about back in last unit. And that rule, that overarching rule is you always need 2 points to make a line. I want you to write that down as well. You always need 2 points to make a line. That being said, there also are exceptions to this rule, or maybe not exceptions, but adaptations. Remember that last unit in 3.5, we weren't usually given 2 points. We were given a point and a slope. Well, if you have a slope, you can find a second point. So we're also going to say, if you have, or if you know, a point and a slope, you can make a line. Because again, if you know a point and you know how much your equation is changing by, you can find another point. 4.1 is going to be all about using a point and a slope to help figure out what the equation of a line should be. Let's take a look at page 99. Starting off, we're going to be looking at problem number 3. Number 3, well, in fact, for problems 1 through 6, our goal is to write the equation of a line with the given slope and y-intercept. Before we go any further, I think it warrants a little bit of review. This slope and y-intercept thing sounds familiar, and it should. Whenever you have the slope and the y-intercept, you can always write the equation of the line in this form. Y equals mx plus b. Now, what do we mean when we say y equals mx plus b? What we mean is y and x are related to each other. But what does this m and b mean? As a reminder, m is always going to be your slope, which will usually be a fraction or a whole number, and your b is your y-intercept. So if I gave you an equation that looked like this, you'd be able to tell me what the slope and y-intercept are. But wait a second. Question number 3 also involves the slope and the y-intercept. And if we're looking for an equation that looks like this, can we take this information and apply it to this equation? Let's try it out. In a linear equation, you're always going to have your y and your x stay as they are, because the whole point is to see how y and x are related. But we can fill in a couple of blanks here. Instead of m, our slope, it tells us here that the slope is 2. So we just put the 2 where the slope should be. It's m. It's sort of just like matching up the spaces and filling in the blanks. We can do the same for our y-intercept. Our y-intercept is supposed to go at the end of our equation. Our y-intercept is -3, so we put -3 at the end of our equation. Now, this is fine as is, but we know that this can be simplified, and we always want to write our equation of a line in the simplest form possible. To simplify this, we know that adding a negative is the same as just subtracting. So we can rewrite it as y equals 2x minus 3. And that's our final equation. This, in general, is the pattern that we're going to be following for the entire lesson. Every single problem of 4.1 will tell you in some way what the y-intercept is and what the slope is. You just got to figure out how to find that information with what you're given. Again, if you know your slope and you know your y-intercept, you've got a line. You've got the equation. You just need to plug it in. Before I send you off to try a couple of these problems on your own, I want to take a look at a little bit of a weirder one. Let's look at number 1. Number 1 tells us that the slope is 0 and the y-intercept is 9. What I like to do is I like to write out the equation with a bunch of empty space just to show where I need to put that information. Y equals mx plus b, but we want to figure out what m is and what b is. Well, m is the slope. It says here the slope is 0. So y equals 0x. The y-intercept is 9. And over here, our y-intercept should go at the very end. So y equals 0x plus 9. Of course, we can simplify this, because what's 0 times x? Well, 1 times x would just be x. 0 times anything is always 0. So it's the same as y equals 0 plus 9. And we know that 0 plus 9 is just 9. So y equals 9 is your equation. Remember that some linear equations only have one variable, and those are going to either be your straight side to side or straight up and down lines. I want you to try these 4 problems on your own. Pause the video and check back to see how you do. How'd it go? Check your answers here, see how you did. In general, a lot of students said that this part is kind of nice because it's just matching. And I agree. Unfortunately, there are a lot of problems where they won't just straight up tell you the information. It's sort of hidden, and you need to find it. Let's go down to problems 7 through 12 to see what I mean. And we are going to be looking at problem number 9 together. Problem number 9 is a graph, but our goal remains the exact same. We want to write this as an equation in slope-intercept form. Well, this is a little bit trickier because they don't tell us what the slope or the y-intercept is. So how can we write it in slope-intercept form if we don't know those things? Well, the secret is we do know those things. It's just a little bit hidden, and we have to remember a couple of tricks from Unit 3 to help us figure them out. I want you to pause the video again for about 30 seconds. Try looking at this graph and figuring out if we know the y-intercept or if we know the slope. Once you have those, you have your equation. So pause the video, see how you do. Hopefully you've had a chance to pause at this point. Let's see if we can figure out this information. The y-intercept is always just going to be where the line crosses the y-axis. That's the definition of the y-intercept. So I'm looking for where the line crosses this red line. Well, hold on a second. They tell us where it crosses the red line. It crosses at 0, 1. As a brief reminder, when we see points like this, like 0, 1, the first number is always going to be your x. The second number is always going to be your y. In this case, the y-intercept, and in fact in every case, the y-intercept is always going to be where x is 0. So we actually do know our y-intercept, or our b. It's just 1. That's where the line crosses the y-axis, at 1. Okay, so we have some information here. Can we also figure out the slope? Now, there are a couple of methods to figuring out the slope. The first one is a little bit easier, and that's when you have a graph, you can actually count out your slope. What do I mean by that? Well, slope, m, is always going to be our rise over our run. So if we can figure out how much we go up by or down by, and how much we go left or right by, we will figure out our slope. Well, according to this graph, we rise by 2 in order to get to the next point. So this is going to be plus 2, because up is a positive direction. And how much over do we have to go? Well, we have to go 2 to the right. Plus 2. So our rise is 2, our run is 2, so our slope is 2 divided by 2. And what's 2 divided by 2? Well, that's just 1. So our slope, our m value, is just 1. Now, this is just one way of figuring it out, and I like it because it's easier when you have a graph. But there is another way of figuring out the slope, and it's not actually using the graph. It's using the points they give us. Remember that when you have 2 points, there's a formula we can use, the slope formula, to figure out the slope. Again, we have x is the first, and y is the second number. The slope formula is m equals, and this is the one that I hope most of us remember. It's the difference in y minus, or divided by the difference in x. In other words, y2 minus y1 over x2 minus x1. Well, in order to figure out what y2, y1, x2, and x1 are, we have to assign which of these points is number 1 and which of these points is number 2. And as a reminder, it doesn't matter which is which, as long as you're consistent. So I'm going to pick, let's say, this one will be point number 2, and this one will be point number 1. Why not? And you could do it the other way around too, and it will give you the same exact answer. That means that this is y2, this one is x2, this is y1, this is x1. So all we need to do is plug this into our formula. We look back and we ask ourselves, what's y2 again? Well, it's 3. What's y1? But 1. x2 is 2. x1 is 0. Now we just need to simplify. 3 minus 1 is 2, and 2 minus 0 is 2. Oh, hang on a second. We got the same exact answer. 2 over 2. So no matter which method you use, you're always going to get the same slope. In this case, our slope is 1. So when we write out our final equation, we're going to write it out, and I'm going to use the space over here because I'm running out. We're going to write it as y equals something times x plus something. In the first blank, we're going to put our slope, which we know is 1. So y equals 1x. And we already said that our b is 1. So our equation is y equals 1x plus 1. And can we simplify this? Sure. 1x we can rewrite as just x. And then we keep the plus 1. So the final answer for number 9 is y equals x plus 1. What I'd like you to do is I would like you to actually try out number 10. Again, pause the video, try it out, and check your answer. How'd you do? This one is a little bit interesting if you were using the counting method for slope. In general, we want to count how much down and how much right we have to go. But we have a little bit of a problem here. Our scale isn't going up by 1 every box. It's counting up by 2s. So this would be 2, this would be 4, this is 6, 8. So the counting method works a little bit differently. You have to count each half box. So when we go down, we're actually not going down, that would be 4.5. We're actually going down 9, minus 9. To get from 5 to negative 4, that's 9 away. Then we use the same logic here. We're not going over 1.5. To go from 0 to 3 is 3. So your slope is actually negative 9 over 3, which is just negative 3. Alright, let's see if we can apply what we learned here on the back side on page 100. We should have a celebration, we finally made it. This time, we're not given a graph. We're just given 2 points. But we already know that for this unit, the information is hidden. They're always going to give us our y-intercept and our slope. We just have to figure it out or solve for one of them. Let's take a look at problem number 13 as we try this one out. If you already think you have an idea how to do it, go ahead and get started. We always need our slope and our y-intercept. I'm going to write out y equals blank x plus blank. Remember what I said a couple of minutes ago about the y-intercept? It's always going to be where x is 0. Even though we can't see on the graph where x is going to be 0, look at our 2 points. Is there something interesting about one of them? This first point, we have x is 0 and y is negative 4. Well, hang on a second. If x is 0, that means that this has to be our y-intercept. Our y-intercept for this problem is negative 4. So to find your y-intercept, always look for where x is 0. Let's plug that into our equation. We know that this is going to be negative 4. But now how do we find the slope? When all you have is 2 points, you have to use your slope formula. We have to figure out how much the y's change by and how much the x's change by. To figure that out, we're going to have to do y2 minus y1 divided by x2 minus x1. We're going to pick one of these points to be point number 1 and one of these points to be point number 2. I'll just go in order. We'll say that this is point number 1. This is point number 2. I recommend you label x1, x2, y1, and y2, but to be honest with you, I'm running out of space here. So I'm going to just look at the problem itself. I'm going to look at the actual coordinates and see if I can pick out my variables just from looking at it. Well, if I'm looking for y2, I want to look at my second point and find the y value. Well, y is always the second number, so it's 4. We can apply the same for y1. We're going to look at point number 1, and which one of these is the y value? It's -4. So we put a -4 here. Again, it is convention to write parentheses when you have minus and negative. It's just sort of the right way of doing things. From here, we can think about the x's. x2 is the first number in point number 2, so that's 8. And over here, x1 is 0. So what's 4 minus -4? Minus a negative is the same as adding. So we can write it as 8. 8 minus 0 is also 8. So our slope is 1. That means our equation is y equals 1x plus -4. Can we simplify this? We can simplify it in two ways. We can start off by getting rid of the 1, just having our x, and plus -4 is the same as -4. So y equals x minus 4. We have 2 more problems to go, and then we will be all set with these notes. The next problem type is going to be a problem like number 22. Now, this is in function notation. Uh-oh. We talked about this in Unit 3, but if you don't feel that you're comfortable with it, I would recommend going back and reviewing section 3.3. Function notation is a way of writing information in a very compact way. It's always going to tell us the input and the output all in one place. As a reminder, your input values are always going to be what are inside of the parentheses. So our input for this first one is 0, our input for the second one is 7. And input is the same as x. So what it's telling you is one of your x values is 0, one of your x values is 7. Your output is f of 0. So whatever f of 0 equals will be your output. Well, in this case, it tells us f of 0 equals 10. So 10 is our y value here. F of 7 equals -4, so -4 is our y value here. What I recommend you do is you take a look at this information and rewrite it as coordinates if you don't feel comfortable with function notation. If our x is 0 and our y is 10, for instance, we can rewrite it as 0, 10. If our x is 7 and our y is -4, we rewrite it as 7, -4. It's just a matter of remembering which is your input and which is your output. Hang on a second, we just did a problem like this, right up here. As a reminder, they're always going to give you one point, well, for this section at least, a point that is the y-intercept, and we find the slope based off the rest. I want you to see if, using these coordinates, you can practice and finish the problem. Go ahead and try it out. Come back when you're ready. Did you get it? With this problem, the point 0, 10 is our y-intercept because x is 0. So our b value is 10. If we look for our slope, we have to use the slope formula, pick a point to be number 1 and number 2, and then plug everything into the formula. You should have gotten -14 over 7, which is -2. So your whole equation is y equals our slope, -2 times x, plus our y-intercept, which we decided is 10. Last problem is problem number 25. And this is one of those linear models I had mentioned. When you have a word problem like this, that you want to find an equation for, the most crucial thing, again, just like all the other problems, is to figure out what represents your y-intercept and what represents your slope. This is extremely tricky to do for a lot of people, especially if you use the words slope and y-intercept. If you had a graph, it makes sense to think about the slope and the y-intercept because you can see it. When you have coordinates, it's sort of trickier to think about the slope and the y-intercept because you can't really see the intercept, and you definitely can't see the slope. It's even more so when you have a word problem. When you have a word problem, the words slope and y-intercept can be extremely confusing. Let's try to rewrite the words slope and y-intercept to make a little more sense with word problems. The slope we can think about as our rate of change. It's how much we're changing by. If I was to go back, for instance, to this page, we could see that the rate of change is just figuring out your change in y divided by your change in x. We're going to do something very similar on this page, but it is going to be a little bit different, so stay tuned. Another word for y-intercept is initial value. Initial or starting value. Just like how you start graphing by using your y-intercept, an initial value is a starting place for a word problem. So, let's take a look at this problem and try and see if we can figure out what our initial value is and what our rate of change is. An electrician charges an initial fee of $50 and $190 after 4 hours of work. So they're charging you $50 up front, and then after 4 hours of work, they charge you $190. Well, let's take a look. What here is our initial value? It's 50. So our B value equals 50. That's the starting place. Then they charge us for $190 after 4 hours of work. To figure out our slope, our rate of change, we have to figure out basically how much we're being charged each and every hour. Your rate of change is always going to be something per something. Like miles per hour, or dollars per gallon, or centimeters per coconut, whatever it might be. It's always going to be something per something. Well, here we have $190 per 4 hours of work. Can we figure out how much they're charging for 1 hour of work? Well, to figure that out, we just have to do 190 divided by 4. Well, if we do 190 divided by 4, we end up with 47.5. To check if this is our rate of change, let's ask ourselves what the units are. Well, on top we have $190. On bottom we have 4 hours. So this is $47.5 per hour. This means that this is our slope. And it also helps us solve problem B. 190 over 4 is 47.5. Of course, since we're talking about dollars per hour, we want to put it like this, $47.50. But if we have our B and we have this slope, this rate of change, we can now write out our equation. Our equation is, or in this case they call it our linear model since it's a word problem, y equals 47.5 x plus 50. Or you could write it as, if you wanted to keep the fraction, 190 divided by 4, x plus 50. In fact, I'm going to write that down to the side just because if we ever needed to graph this, for instance, it's a lot more useful to see your rise and your run. And that's that. All right, thank you so much, everybody. I hope you have a fantastic day, and I will see you next time.